Same person, like same name.
Why did you move from Connecticut?
Because it's cold.
Connecticut's not cold. What? Well, it's not like Montana.
Oh, I'm sorry. We're comparing two really crappy places. We live in California now.
I left because my wife didn't like that.
Good woman.
Ever been to
So, Eric, maybe I'll introduce you a second. You don't both like Connecticut. Oh, yeah. Guys, since I don't have much time left in class, can I cheat? Instead of trying to make something up out of thin air and goof it all up, can I look? 'Cause I know I've made up examples in the past. Because I was going to discuss this days ago. If I can find it, you can't cheat. No, sorry. Oh, I found it. Oh, notice something nasty about this technique. I didn't write it fully. But if you solve this system of equations, what it gives you are points at which you optimize the output of the function z. It doesn't tell you if it's max or min. So keep that in mind. Sometimes you're going to have to think about it. And what if I'm trying to optimize the output of this function subject to this constraint? So do you guys think there is an answer to this question?
Wait, so plugging that into that formula, then you're going to say that f of x equals lambda times
Well, careful, that's the gradient of f.
the gradient of f equals lambda times the gradient of the subject to blah, blah, blah.
Right, I agree. So in this example, what's my g function?
X plus y.
I can't hear you.
X plus y minus 1.
I heard that. X plus y minus 1.
Yeah.
By the way, do you think there's an answer to this question?
Since you're giving it, yes.
No, but honestly, can you imagine what is going to be max or min or both?
Can you graph these so we can kind of?
But I was thinking you could say the answer without graphs. I want you to in your head. Here's this by chord of
I'm still
plane.
not visualizing
Isn't
this
it-
yet. I'm not visualizing that yet.
Isn't it going to kind of equal like a...
Thank you. And the xy chord of plane is just a line. My tabletop is the xy chord of plane. There's a line. Who cares where it is? And the surface of the 3 space is nothing more than a downward pointing circular paraboloid.
Yeah, like a bowl.
So if I got a bowl that goes on indefinitely, then along that line, do you think I'm going to have a minimum z value?
No.
No
they're all
way.
the same.
Do you think I'm going to have maximum z value on the surface subject to the constraint that I live on that line in 2 space? And the xy chord of plane. Yeah, I think clearly there's going to be a max. So I think with this technique, I better have an answer. But it'll only be one answer, then it will necessarily be a maximum value for z.
I'm not
Can you
visualizing.
draw a little picture of?
Yes, I can draw a little picture. Here's the x-axis. Here's the y-axis. Here's the z-axis. The graph of this equation right here, isn't that just simply an inverted circular paraboloid? Do you guys agree? And there's some line in the xy coordinate plane. I don't want to be careful with where it is. How about this silly one right here, this horizontal one? But it's living in the xy coordinate plane. I want you to take a walk along this line. Don't you guys agree the further and further I walk to the left, the smaller and smaller my z values in the surface are going to be?
Yeah.
So I don't think I can have a minimum z value subject to this right constraint. But I do think if I were to walk along this line and look up and look down to see the corresponding curve on the surface in blue, I think it's going to be parabolic. And I do think, sorry I'm so sloppy, there's some point on that curve in blue for which I get the maximum z value.
Is it possible that the red function doesn't have any points on the shape?
The line wasn't fun. Isn't that kind of like it wasn't when
Like
Dylan
if
gave
there
the
were-
Gosh, if for an application, I sure hope not.
Okay, so you would, yeah.
That means I don't have a maximum. I'm sorry, I misspoke. That means the question's moot because
Doesn't it?
there's no corresponding z values on the surface. Linda, I'm sorry if I'm doing such a poor job of drawing.
Well, there we go.
You guys, let's answer the question. If I'm going to set the gradient of f equal to lambda times the gradient of g, doesn't that give me this is one of my equations? You guys help me with this. I'll help you. Negative
You're on your own.
2x, I'm on my own, equals, I can't hear you.
Is this the gradient at lambda?
That's the gradient, well, it's the x component of the gradient f.
The x component of the gradient f. How do we know that equals lambda? That's it.
All right, I'll put it more steps. Hold it. I'm skipping too much.
Yes.
Would you guys not agree the gradient for f is nothing more than this vector right here, negative 2x. So negative 2y.
What's your?
And I think the gradient for g is going to be nothing more than, I've lost it, is that a 1, 1? But shoot, you guys, if the gradient of f is going to be equal to lambda times the gradient of g, doesn't that mean negative 2x comma negative 2y is equal to lambda times 1, 1? Doesn't that mean the gradient for f is going to be equal to this vector? Ah, shoot, hold it. Setting x components equal to each other? Oh, look at that, that's my first equation. Setting y components equal to each other? Oh, check this out, there's another equation. And I've also got the constraint equation as well. I had just listed on the board 3 equations of 3 unknowns. Now I have to confess, you guys, I didn't realize with this example, these 3 equations are linear. So I gotta confess, if you really want to, you can go ahead and rewrite the system as augmented matrix, use Gauss-Jordan elimination to completely reduce that matrix. If you don't like what I'm saying, you can use the inverse matrix method by rewriting the system of 3 equations, 3 unknowns as a single matrix equation and using inverse matrices to solve that system. For those of you who take Math 30, you can even use the adjoint to do that if you so choose.
What if you don't remember all that?
Then you can use Cramer's rule.
What's Kramer's rule?
Is using determinants to solve a system of linear equations?
I'll have to look that up.
Oh, you make me cry. Okay, so you don't use any of them. I'll use something else. I don't know, let's panic. Let's rewrite the second equation. Sorry, misspoke. Let's rewrite the second equation in a different fashion. Look at my first equation. What's another name for x?
1 minus y.
So negative 1/2 lambda. And looking at my second equation, another name for y, and my second equation is, so negative 1/2 lambda. Oh shoot, look what I just done. With those 2 substitutions, I created 1 equation, 1 unknown. I could solve for lambda. I guess that tells me that lambda is equal to negative 1.
Oh, wait a minute, so you, oh, okay, so you play this second.
Am I getting too sloppy, you guys? That's a lambda. Maddie?
No, I got it.
Oh, I forgot what I'm doing. What am I trying to find? At what point do I maximize the output of that function? Shoot, and I found lambda. I guess it doesn't answer the question. So my final answer. It's going to be in an ordered pair, where x is going to be, oh, look at this, that relationship. If I plug negative 1 in for lambda, what's the corresponding x value? 1/2. I agree. Are you happy? Are you happy? Because I'm not. I think the example was too.
Easy?
Yeah.
Hold on. Wait, answer,
Yes,
so you plugged in.
Yes. All I did was this. I took this first equation, and I said, well, if lambda is equal to negative 1, then I guess that means x is equal to 1/2.
Oh.
And then I took the second equation and said, well, here too, if lambda is equal to negative 1, then I guess y is equal to positive 1/2.
Okay.
Happier? Well, let's see if I can put a little meat into this. You guys, I really do want to put some meat into this. I don't have a lot of time. Shoot. You know what? I think this will be nice. Ooh.
Can we do it with type inverse hyperbolic sign?
Maybe I'll get there, yes. How about a function of 3 variables? being equal to x, y, z. Subject to this constraint relationship. So do you guys, before we get started, do you guys mind if we just talk? Because the question is, let's you and I optimize the output of that function f subject to this constraint. But I think the output of that function is another variable, call it w. I think this is a surface that lives in four-dimensional space. But I want to ask, how do I maximize that w value, that fourth-dimensional component's value, when I live on this ellipsoid in 3 space? Now, I know it's hard to visualize because this is abstract. We're optimizing the output of the function in 3 variables, subject to living on the surface in 3 space. But I think the same thing applies to my last example. It's just the gradient vector is going to have 3 components, not 2. So, do you want me to show all my steps or not?
Yes.
Yay! Okay. Would you guys agree that this is the output of my function g? Since it's already set equal to 0. So I maintain, I might need room, shoot. I maintain the gradient for f as a function in 3 variables, as a vector valued function of 3 variables, is nothing more than, oh, that's easy, isn't it? 8yz, comma 8xz, comma 8xy. I think the gradient for g as a function in 3 variables is going to have these components. Well, that's not bad. Is that a 32x? Is that a 8y? And finally, is that an 18z?
So, like, what I'm getting at so far right now is that this just seems like plug into an equation, get lambda, and get your points.
Wait, stop. In my last example, I got lambda. It doesn't, I didn't mean to suggest for that first example I'm always solving for lambda. I'm panicking. I'm solving for anything I can solve for.
Okay.
And it might not be lambda. Maybe you can directly find values for x, y, and z. I didn't mean to mislead you with that example.
Directly find values for x, y, and z? What do you mean?
Well, in this example, sorry, just for x and y. In the end, I wanted that point in 2 space that optimizes the output of function f.
So we're not always going to need lambda to find that.
No, you're not. As a matter of fact, in general, you're going to have a system of equations that are not necessarily linear. And as a mathematician, I can't even give you a technique for solving a system of equations, a concrete technique for solving a system of equations when they're not linear. My last example was easy, they were linear. But my previous example, that application was not linear as a system. So when you set up these individual equations, solve for something, you're going to solve for just that, something, whatever you can solve for. And the last example is kind of neat, that it was lambda. I like that. But then I had to backtrack and find out what the x and y values were relative to that value for lambda. And I'm sorry, you guys, I can't look that far ahead with this example. I don't know if I'm going to do that. So let's check it out. I think I'm going to set the gradient of f equal to the gradient of g times lambda. And so I see that 8xy, ooh, I misspoke, everybody. I meant 8xz, comma 8, I still made a mistake, didn't I? I can't even copy the first component. Is that an 8yz, then an 8xz, then an 8xy? I'm going to set this equal to my 32x lambda, comma 8y lambda, and finally my 18z lambda. But I think that gives me the following system of equations. Setting the first components equal to each other, does that tell me that 8xz, I still can't write it, jeepers, 8yz is equal to 32x lambda. Setting my second components equal to each other, that's 8xz being equal to an 8y lambda. And finally, 8xy is going to be equal to an 18z lambda. You know what? This isn't going to work. That's 3 equations. 4 unknowns. I need another equation. Where does it come from?
From
The constraint relationship, the ellipsoid. So my 4th equation really is 16x squared. You guys have took my glasses off. Is it 4? And then what else? 9z. Got it. You know what, I'm starting to like this example, because unlike my last example, this is a system of 4 equations, 4 unknowns, that is a non-linear system. So I really do not have one technique.
We're still writing it down.
I'll
Can't we just run the knowledge root of x into the last equation again?
Could you just solve that first 3 and then like get something?
I don't, that makes me nervous, Matthew, because if you just look at the first 3 equations, they involve 4 different unknowns.
Or maybe you can get like something you can plug into something else in the bottom one and then get some.
Now that sounds nice, I like that, he's saying put things at the bottom.
If you solve them all for lambda, don't they all equal each other? Then you have 3 equations, 3 unknowns, or is that not?
Well, that sounds complicated, because I solve for lambda in each of these 3, say each of these 3 things equal to each other, that's like 1 equals another. They have too many variables in this. Not too many variables, but I don't think it's a very pretty equation to work with. I got fractions all over the place.
That's how I've been trying and they've been canceling it. That's
You know, I kind of like the idea, though, kind of last equation. Let's just replace x squared with something. Now, for my first equation, x squared is, whoops. Oh, I don't see an x squared. But, if I multiply both sides by x, I can see an x squared. And just because I'm tired, can I use my math skills and kind of clean it up a little bit by dividing both sides by 8? And I think that tells me, from the first equation, that x times y times z is nothing more than the 4x squared lambda. Yes?
How do we know that x isn't 0?
You know, that's a good point. I think if x is equal to 0, though, isn't that going to force either y or z to be 0? But let's say, for example, y is equal to 0. But if y is equal to 0, then I think that's going to force z to be equal to 0. And I think all the points would be 0, or excuse me, all the coordinates would be 0, but you wouldn't be living on that ellipsoid. Doesn't satisfy the equation. But good point. And I think if I multiply both sides of the second equation by y, doesn't that give me x, y, z is equal to y squared lambda? And finally, multiplying both sides of the third equation by, how about z, and simultaneously dividing both sides by 2 because I can. Doesn't that tell me that, sorry so slow you guys, doesn't that tell me that 4 times x times y times z is equal to a 9z squared times lambda? So, using my 4th equation, let's you and I make a triple substitution. I will, number 1, replace x squared. Alex?
Don't we have x, y, z in the top 2 equations? So can't we just set those to equal to each other? 4x squared lambda is equal to y squared lambda?
Okay, but that's 1 equation and 3 unknowns. Now I could try another pair, but that's going to be another equation and 3 unknowns. So I think it still complicates the issue. You guys, humor me. If I were to make a substitution, for this first equation, I think another name for x squared is just x, y, z over 4 lambda. I think with my second term, I got a 4y squared, but y squared, according to the second equation, has an alternative name of x, y, z over lambda. And my third equation tells me another name for z squared is 4x, y, z over 9 lambda. And when I subtract 1 from 44, set it equal to 0, maybe I can play with this equation. I don't know. I'm sorry, I can't do that much in my head. Is it 12? Write a single x, y, z being equal to 12 lambda. You guys double check my arithmetic? Nobody wants to check my arithmetic.
Nah, we're good.
Matthew?
So, I don't know, I want to say it's easy, but it just seems like, you know,
Well,
you're just
everything's-
plugging stuff in, solving, and then, like, doing that. Like, is there going to be, like, a, like, something harder that we can do? Like,
I would venture to guess, if I sent you home with this example, you would have thought this is complex, in the sense that you've got to decide how to solve the system. I think, Matthew, if you can follow my example here, this is about as sophisticated as it's gonna get.
Well, like, are there gonna be word problems?
Oh,
Like,
sure, every problem outside the math class.
So is this like, RSLink where there's limited examples that we really can do?
You know, to a certain extent, yes, because I suppose with an example I created out of thin air, it could lead to these equations
You could
which
have
are difficult to
fractions and
solve.
transcendentals and all kinds of.
Yeah, and it's not the case that every single equation you come across you can solve.
Right.
Oftentimes, we have to use an approximation technique. Good point. Maddie?
I'm getting pretty sick.
Well, did I make a mistake? So 4 of these things plus 4 of these things plus 4 of these things is 12 of them.
Oh, yeah.
And 12 of them being equal to 144, I divided both sides by 12. And then I multiplied both sides by lambda.
I was backing out of where I was combined.
Gotcha. You just tell me if I made a mistake.
So,
Yes.
I'm still not seeing, what are we supposed to do after this? Like,
Good point. Oh,
do
no
we
pun
got
intended. We're trying to find the order triplet x, y, and z that maximizes or minimizes the output of my function. So I'm trying to find an order triplet x, y, and z, or maybe multiple order triplets.
so you would plug that into that, and you'd say.
Oh, no, hold on, I don't have my glasses. Got it to what?
So
I already did.
say
That's how I got this.
Z equals 12 lambda, and then,
Z equals 12 lambda.
and now if you plug x, y, z back into 8,
in other words, you have yz equals 12 over lambda, 8 times 12 lambda over x equals 32x lambda.
But are you plugging that back in over here?
yeah,
Well, how do you get z equals anything?
because like x isn't f of x, y, oh, wait, that's
No,
w,
Matt.
that's w.
I see. So W is equal to 12 lambda, it doesn't tell me anything though.
Okay, yeah.
Well, 8 times 12.
I'm assuming you want to plug it into these equations you just got right here.
Beautiful. Let's do it. With this equation right here, if I replace x, y, z with 12 lambda, check this out. Space. Doesn't that tell me this? Doesn't that tell me this? Can I do this? Again, that's just to enforce all the x, y needs to be 0. But that's not a point on the surface that's described by the loop. Now, I maintain if I were to take the second equation, here too, you guys, allow me to replace x, y, z with its alternative name down here, which is 12 lambda, and here's a relationship I get. I can rewrite that, use my math B skills. Does that tell me that lambda times 12 minus y squared is equal to 0? But that necessarily implies that y is equal to plus or minus, is that a 2 root 3?
Or root 12.
Yeah, my version looks nice. And finally, with that third equation, I guess that tells me that 4 times 12 times lambda is equal to 9z squared lambda. But that applies. You guys make me do all the work.
48 over 9, root 48 over 9.
I can't do it.
Yeah, 4 root 3 over 3, plus or minus.
You guys, is that correct? I'm sorry, I'm fading. I'm tired.
Yeah, no, you're right, 4 root 3 over 3.
But that necessarily implies that y is equal to plus or minus, is that 4/3 root 3?
Yeah, yeah, but it's z, it implies z is.
Oh, my apologies, thank you. I wrote y, it should be z. There's too many points.
Yeah, doesn't that potentially give us 9 different equations? Or,
What do you mean different points?
yeah, sorry, different points, different sets. I mean,
How many?
is it? No, I'm sorry, not 9.
How many?
Isn't it 6? You have 1, 2, 3, 4, 5, 6, 7. No, but maybe.
You guys, how many were there? Or 8? 8. 2 cubed.
Oh, because there's 3 2Ds. Okay. You do the same thing with heterozygous pairs in biology. I just got that.
Very nice.
Just
Wait,
makes
go
sense.
back. Why is it 8, not 9?
Well, I got 2 choices here. For each of those choices, I get 2 choices here, that makes 4. But for each of the 4 choices, I get 2 choices here. So 4 choices plus a positive one, 4 choices, and then a negative one gives you 12 of 8. I'll say it differently. How many different subsets can you create of size, whatever you have there? It's just counting how many subsets you have.
3 squared.
Matt? Just brushing.
I couldn't decide if I
Okay. You guys, let's answer the question. I said, you guys, let's answer the question. I can answer the third one.
Quite frankly, we don't know yet.
I guess we do.
They all be positive?
If they're all positive, I think we maximize it.
Wait, are we writing out all of them?
You bet I am.
What?
Why?
Because I asked you to.
Are there multiple,
Give me another one then.
when 2 of them are negative
Very nice.
and one's positive? Just looking back at the original equation. A lot of work.
No, this will finite numbers. It's only 8.
Yeah, but what's the one?
Negative, positive,
Negative.
I do.
Negative, positive.
negative, positive, negative.
That's a good computer sport.
I'm on a desert island. I don't have a computer.
Negative, positive, positive.
Maximize our 3-dimensional space is the only way to survive.
I would survive, but still be able to think. I don't want Alzheimer's this year.
You don't want to be talking to Spalding? What? Or Wilson? Not Madagascar.
What's Madagascar?
Oh, Jesus. It's a Disney movie. And
Oh.
in the movie, he's got I think it's a basketball, and he goes to Spalding, it's a Kraken, Wilson.
I was thinking of, I've never seen Astro.
Yeah, it's a Kraken castaway.
I can't hear you.
That's what we're not saying.
Negative root 3. Negative root 3.
You forget who assigned the letter grade your name again.
All negative.
Negative
All
2
negative.
root 3.
I heard that.
Yeah, more negatives.
Wild guess. Did you see Wyland?
1 negative and 2 positives.
1 negative, 2 positive.
And
There's 3 different ways I can
do that multiple times.
So let's say we're lazy, and can we just use like plus minus?
Well, no, you couldn't because I don't know which one's maximize, which one minimizes the output of the function. If
Or
you
just say, so we max and minimize.
Well, technically speaking, that would be correct because you can't have a point that maximizes and minimizes simultaneously in that
Or
application.
minimize. Wait, so how do you know anyway? I'm confused.
Maddie, check this out. Go back to my function f and look at the output. Notice how the output is a product of x, y, and z. And I think if all 3 are positive, all 3 values for the variables are positive, this number is positive. But I think if any 2 of them are negative, then the output's still positive. That's why with the collection of ordered triplets, to maximize my function f, notice how all 3 are positive or 2 of them are going to be negative.
Isn't only one gonna be like the max?
True, but if I ask the question, at what triplets do I actually maximize the output of my function f? Here are the triplets for which I maximize the output. And they'll all be the same number when you actually value the function, but the output occurred at 4 different points on the surface.
Which makes sense.
Yeah, because of all the symmetry, it makes a lot of sense. And I think these 4 points actually minimize the output of my function because, jeepers, when all 3 are negative or just one of them is negative, I think the output of the function f is clearly negative.
Technically, if you ask for the max, we shouldn't have to write the thing before.
What's that?
Well, if you ask for the max values, we shouldn't have to write out the second one.
No, I agree. That's why I'm saying, if I asked you to give me the order of triplets that maximize the output of my function, give me all 4 of these. Do you guys agree?
What did we ask for?
I don't know, because I probably did a poor job. With this answer, I really meant to ask that question. Can you give me the order of triplets for which I optimize?
Yeah, you actually, there was nothing regarding optimization at all.
Yeah,
It was just,
let's just say,
you just gave us a
using
problem.
Lagrange multipliers to solve the situation.
No, optimization means
Can we always use,
all your max examines.
Yes.
can we always use Lagrange multipliers?
No. Lagrange multiplier technique only applies when you've got some kind of constraint relationship. If I ask you to find all local extrema for the output of some function in two variables, like a sheet in 3 space, you gotta use a second derivative test. Well, I say you gotta use a second derivative test, unless it's obvious, like you got a parabola opening down or up. I guess you can just look at it. But I wouldn't give you a question like that. So, relative extrema, second derivative test. Absolute extrema over some closed region in 2 space, you have to use that advanced math-theory technique I gave you last time, where you find local extrema on the interior, and then you find absolute extrema on the boundary curve. But now, if I'm asking you to optimize the z-values in a surface or even higher dimensional space, subject to some constraint relationship like an equation in the xy coordinate plane or a surface in 3 plane, in the 3 space, then Lagrange multipliers is a perfect technique.
So these give us the max and mins. Do they tell us anything about the other stuff like saddle points or?
None whatsoever. It only tells you where those 2 gradient vectors are going to be parallel, period. So Lagrange multiplier technique is really
So are you gonna give us a question, a test that says find a max and min or local max and min, saddle points, whatever, now draw it?
I don't see, like, drawing it wouldn't be that hard, that's the thing.
I would only be able to do that with a simple example.
Okay.
But you know, I could do that because you've already demonstrated last exam, you're experts at sketching surfaces.
I'm not.
Oh, jeepers, I know it's so late, sorry.
Can you tell us what we're going to cover on the exam next week?
Yes, I can. Let me first give the assignment.
Okay.
I don't know where we are. What section?
So we're definitely gonna have an exam.
Let's talk about it. So 12.9.
Yeah.
5. 5 through 17 odd.
My coworker was asking.
No, 9. Odd. 21.
Sorry, 5 through 17,
Odd.
And then 21?
21. 25 through.
Do you actually, like, read each individual problem or just read the section?
No, I'm very brief. Where did you finish off? I said
25 through.
Dot, dot, dot.
Dot, 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 yeah.
Waiting with bated anticipation.
45 odd.
25 through 45?
25 through
Odd.
what?
Say it again.
25 through 45 odd. All right, I'm happy with it.
And then do you want to sign application homework for 12.8?
Yes, I do, thank you. Back in 4.8, or 12.8. Back at 12.8. $67. Oh man, you've got so much technology in these questions, don't it? 67.
You've already given us 15 through 47 odd.
Throw in 49 and 51 as well.
49 through or 49 and?
49 and 51 as well.
67 you said?
Yeah. The rest, he's got a few more, but they all require technology. As far as the exam is concerned.
When is the exam? Like 2 weeks from now, right? Like all of
Let me look first.
Isn't it next week?
Yeah,
Like,
he's
yeah.
kidding.
Friday, right?
I mean, we could do 2 weeks from now. We don't have an exam for like a month until the final. Yeah, isn't it just this next exam, right? And then no, we have 2 exams, and then we have like a good 3 or 4 week break in between the final.
No, let's just do it.
No, cause I thought we have.
The example covers through from
Yeah, but we have a good break in between the final and the 4th exam.
13.2.
Yeah. Which one? What is it?
I'm sorry.
That means I get to talk on that.
Exam for, what section?
What is it?
I said 12.4 through 13.2.
And so that's on Friday, right?
Yes.
And the math comes on Friday. So could we like start the test early?
The math conference is at that too.
Oh, wait, I didn't.
Thank you.